Okay. We're going to start. Okay, so now that we are finished our first half of our first semester, our first year, we are kind of in the latter half where we have approximately 5 weeks of content left to cover. And again, this is a linear course, which means that we're going to be running from September to the end of April, with no examination or no final examination in the middle of that. So that's good from the point of view of we are still not in any rush to get through content. We are slightly ahead of where I initially had planned, which is great because it means it gives me more time to do revision before our class tests. It also means that if we hit a sticky topic, I can stop and I can spend more time on that as well. But we are in week 9 at this point. However, my intention is to start on to strings today, unless there are specific questions about loops. Our string questions will mainly revolve around loops as well, so we'll get more practice there. Your current timeline is that your workbook is due for next week, but I did say when I issued it, because I forgot to actually upload it on time, that I'm happy to push that out by a week. But if I push that out by a week, you're still going to end up getting your first assignment from me next week. Then you'll be submitting your worksheet. And then what I could do is I could push out the assignment 1 to be the last week of the semester. And workbook 2 will be issued in the second semester. So workbook 2 is kind of in the second semester there when we come back after the January break. So you have a good period of time to work on that. So that's where we sit at the moment. We're at week 9. I have strings, string manipulation methods to look at. I might begin into the idea of arrays, which will be our first topic in the second semester, depending on how well the class is going with it and also how much time you want to spend on particular topics. Okay. I've also uploaded the next couple of weeks worth of notes. I've uploaded strings, and I've uploaded what do I have here? Methods and arrays, which would be, if everything goes perfectly well, that is all I'm going to cover up between now and the new year, and everything else remaining in the course will be left for the second semester. If things don't go perfectly and we need more time to work on topics, well, then that's fine. They just get pushed into the second semester, and we have time there as well. As I said multiple times before, first year is not a intensive course from the amount of content we have to cover. The intensity comes from the point of view of just getting used to using the code and actually writing solutions to the problems. The content we have to cover isn't massive, which means that there is space to slow down or to speed up depending on how the group goes. Okay. So I suppose what I should do is I should start off with figuring out how people feel at the moment. At this point, based on what I've covered, we've done those first 5 elements that allow us to make useful programs. We have, excuse me, we have a way of printing the screen. We have a way of taking in user input. We have a way of storing values into variables. We have a way of asking questions and evaluating questions inside our code, and we have a way of doing loops, of doing something multiple times. So the combination of those 5 elements will allow us to look at strings, or look at methods, or look at arrays, or look at file access, or look at sorting. And we should be able to be, once we get around the idea of whatever the topic is, strings, it's just a collection of characters, we were like, oh, well, it's a collection of characters, and I'm going to work with them by using loops and if statements and variables and user input and print it to the screen. And so we're just going to reutilize those 5 first elements over and over and over again in different combinations to get our programs to do what we want them to do. So based on the last group of classes that you had, the first set of classes you had, is there anything that is not 100% that you'd like me to go over? Would you like me to pick an example and do a large example or a larger example problem, so you can kind of ask me questions as I'm going through the code, and then we can start to look at strings after that point. Are you happy with what you've done so far? And you want to move forward with the string stuff? A good indication, I have some nods, and that's kind of, I've asked 2 options, so nods aren't useful. A good indication of this is think about the workbook, right? In that workbook, you have 7 questions. The first 2 questions are just to do with variables and evaluation. No user input. I have a variable, I'm going to do some assignment or some operation, I'm going to print out an answer. The next couple of questions are dealing with, actually, let me see, have I got Firefox open? The next couple of questions are dealing with user input. So, workbook.
There's not Wi-Fi here that I can log in.
There should be, yeah. So if you click on your right there, if you go with GC guest Wi-Fi there, go the second one to the top, yeah. And the password for that is Griffith College. It's capital G or 1FF1TH, and then college capital C OLL 3G3. So in Griffith College, capital G, capital C, the I's are replaced with 1s, the E's are replaced with 3s. Okay, and I can't see workbook 1. That's not showing. Right, let me go. Let's go in here and have a look at it. Is that connecting for you? Yeah, if it's asking that question, that's probably a good sign that it is connecting. No, you and the full timers have the same content. Thank you. There. Okay, so your first 2 questions are just dealing with variables. Okay, so if you've done the first 2 questions, you're comfortable with that. Well, then that means that probably from the point of view of printing to the screen and taking or using variables, you're probably okay. The next 2 questions are dealing with user input. So again, if you've got through the next 2 questions, you're probably okay from the point of view of user input. This is a tricky one, the last digit value, but that's only because you need to use the modulus command for that. The next couple of questions are dealing with if statements. Are dealing with if statements where we start off with the months of the year. You enter 1 through 12 and it tells you, yes, that month is whatever, or you enter below 1 or above 12 and says, no, that's not a month. And then this is probably the one that costs the most amount of. It's the most interesting challenge, let's put it that way, rather than the most amount of anything. Nightmare, I think, is a strong word.
It's appropriate.
Okay, fair enough. Okay, and then our last question is to do with loops. So we have 2 questions on if statements, we have 2 questions on user input, we have 2 questions on variables, and our last question there is to do with loops.
It's a quick one on question 6, is it?
Yes.
Are we taking leap years into account for that?
Ideally, yes.
Yeah.
So, what I would suggest doing with this is if you think about that nursery rhyme that we all learned, there are 30 days in September, April, June, and November. That one. You can approach this from the point of view of having, if month is equal to 1, then you have all your sub questions inside that. Well, make sure that the days between this and this. If month is equal to 2, well, then make sure that your days between this and this. We'll ignore leap years for a moment. You can iterate down through each of the 12 months. You can have 12 if else if statements. And then you have an else at the bottom. But no, that's not a valid month, so we're not going to accept it at all. And then inside each of those, you almost have the same code. But if you look at that code, there's an awful lot of duplication. You're going to have, I think it's 5 months that are, off the top of my head, I think it's 5 months that will all be going with 31 days. Yeah. There are 6 months that are going with 30 days, and then there's February. So February is always going to be an anomaly. It's always going to be a category on its own. But if you think of the months of 30 days and the months of 31 days, it is possible to group them all together. Now, if at this point in time, with the deadline coming up soon, whether it's next Monday or whether it's the Monday after that, it's probably more important to get the solution, like to get the problem working, than to say, oh, here's the neatest, fanciest way of doing it. We will get to that point at a later stage. The trick with not having 12 if statements, one for each of the month, and then having the same question for the number of days repeated through the code is using our logical connectors, our AND gates and our OR gates. But if you can't get around that at the moment, well then have 12 if statements. That's absolutely fine. The way I will grade these questions, I will run each code. I will enter in a sample value. I will see if it gives me the output I expect it to. I will quickly look at the code itself. So for example, with the second question there, swapping two numbers, I just want to make sure that you haven't just printed out the value back saying, here's the value of y, that you actually have swapped the values. And once I can see that the code does what it's meant to do, and it actually does what it's meant to do, well then I'm fine with that, and you're probably end up getting full marks for it. If, like each of these questions, the entire worksheet's worth 5%, and I have 7 questions. Each question is worth somewhere between 1 or probably 1/2 of 1%. I'm not going to be saying, oh, well, that's not the most efficient solution, so I'm going to dock you 10 marks out of the 1% going for it. For now, your question's only getting 0.9 of 1%. I'm not going to do that. If it works, it gets the marks. If it doesn't work, it'll probably get half the marks. That's the way I usually grade the worksheets because they're small pieces of code. When we look at the larger assignments, yes, you will have a much bigger matrix or rubric for grading, but I'm very open about what that is. So with this, the way I would do it, the way I would approach it without giving you the answer is I would take in all the input, get that out of the way first. I would then evaluate what month is it and allow that to categorize how many days I'm expecting. And assuming that it's 31-day months, I would just double check, well, is this month, whatever the number they entered in, number 5 or number 2, well, not number 2, that's the weird one. Does that match into the number of days that are valid? Because remember, for most questions, for most inputs in that program, it's going to be a valid date. Because in every month you have between 1 and 28. You know all of those are going to be valid. It doesn't matter what the month is. Between 1 and 28 is going to be valid. If it's a month between 1 and 12, you know that's going to be valid. If it's a year that's positive, you know that's going to be valid. So really all you're checking is if the month is 29, 30, or 31. That's all that actually matters on the inputs. And obviously I'm going to be checking for silly dates that don't exist. So I would check the month, and based on the month, be able to categorize, oh, I'm expecting 30 days, or 31 days, or 28 days. And that would be the first way I do it. And when I know that that's working, I would then go back and work out also, if the month is 2, I need to have a look and see is the year a leap year. If you leave the leap year stuff out of it, you're not going to lose any marks because it's a fraction of 1% that I'm doing. So it's kind of irrelevant at the moment. If this were to come up in your exam paper, it would be worth 20 marks of the exam. So 1/5 of the exam paper. I would be expecting leap year stuff. But again, that's an exam you're going to take in May. Okay? So just highlighting from that point of view that make your best attempt at it. I would far prefer you to send me an attempt which is incomplete or which doesn't work quite right than to go off and find it on the internet and copy and paste it or get someone else to do it and not really understand it. Because then it's disingenuous to see where you are. So if I'm trying to gauge how well the class is doing or how poorly the class is doing and the work isn't yours, it's more difficult for me to ascertain that. Also, it's 1 question of 7. So it's annoying. It's possibly a nightmare. It will be probably irritating when you see the solution, but it's just 1 question. And the whole point of this course is that I'm going to give you questions that are going to be challenging to you. And then when you have submitted it and you see the solution, you go, oh, for God's sake. Because you'll see that, oh, there was a neater way or there was a simpler way of doing it. Or hopefully that doesn't happen as much as, yeah, I got that right, or that's almost right. Or what's happened quite often with both yourselves and with the full-time group is, I did it, but I did it this way, which is also a valid, like if it's getting the same solution, it's also a valid entry. And there, what I like to see, because it means that you had a different way of approaching the problem, but you still solve the problem. And then the last question is to do with loops. And again, the way I designed or way I expected the last question to work, although I don't rigidly or strictly mark it based on, well, if it's not done my way, it's going to get 0, is that I assumed that these 3 states here would be linked in at the top of your while loop. So your guard for your while loop would have 3 conditions, and all of them would have to be valid to get into the loop. And if any one of them become invalid, well, then it quits you out of the loop. But that's only one way of solving the problem. There are other ways of doing this. But that's the way I approach it. Any other questions on the worksheet since it's up on the board and we're talking about it?
We're gonna do it in here, or
Bigger?
we're gonna do it in here in class?
I will.
We have to send to Moodle.
You would have to upload onto Moodle, yeah. So if anybody has restricted Moodle access at the moment, email it to me. I'll get it then. So email it for whatever deadline I end up agreeing with you guys. Do you want to move it from Monday? So it's currently on Moodle set for Monday, the 19th. So before we see each other again. Will I shift it to the following Monday? Leave it at the current deadline?
Yeah.
Yeah.
Okay, look, here's what I'm going to do. We will assume that I will shift it to the following deadline. I'm not updating Moodle, but, and again, it's going to be on YouTube, so there isn't evidence of me saying this. I am not going to penalize anyone for submission between Monday the 19th and Monday the 26th. If you submit it any time between then, that's absolutely fine.
Yeah, I prefer because I missed 2 classes, so I still studying.
Cool, no problem. No problem. What I will say is I would advise you to get it in as soon as it's done. Just get it out of the way, off your plate, because as you saw from the previous chart, my aim is to give you a new assignment next week, which will be a 2-week assignment, so that will be submitted before we break for December. And then I will also be issuing you the worksheet. Now, the assignment will be based on everything we've done basically up until today, before I start this topic. So it's going to be an assignment that's going to have mainly revolve around numerical variables, so doubles or integers. Excuse me. And it is going to be something that involves loops and if statements and user input and printing to the screen. Everything we've done up until now, those 5 important things. So I could give you the assignment now, and you would have covered all of the content to do it. Okay? What the workbook will be focused on is the new content we cover between now and the end of this semester. So basically we're looking at strings, we're looking at methods, and we're looking at possibly arrays. And if we don't end up covering the array stuff, well then I will shift the workbook to submission until we get that done. Okay? So the worksheet, we have covered all of the content you need to do that. The assignment that you will get before we finish for Christmas, you have also covered all the content we need to do for it as of this moment. And the workbook 2 will be, as the previous one was, small questions, 1 for each of the new topics, or 1 or 2 for each of the new topics. I don't have there. I think workbook 2 has less questions. I think it has 5 rather than 7, or maybe 4. I can't remember. But again, they're small ones that should be achievable within somewhere between half an hour to an hour per question, depending on how comfortable you are with that topic. Fair enough?
Just to fully understand, we have to answer all these questions.
Correct.
I can do it at home.
Yes,
And I
absolutely.
create the code.
Yep.
And how do we insert in here?
Okay,
Well, that's
so
not how to do it.
see there, workbook upload
Uh-huh.
point. So what you're going to do for the workbook when you are submitting it, either between Monday 19th and Monday 26th, is I want 7 Java files. Question 1, question 2, question 3, question 4, question 5, question 7.
Okay, here.
And you're going to create a zip folder or an archive folder for that. So for most, if you're on Windows, it'll look like this. You are going to go and you'll select whatever, let's say this is my folder here. If I right click on it and I go down to send to, compressed folder will create a zip folder for it. So if I click that, look, there's my zip folder there. Okay? Yep.
Yeah, this is a question. Do you need to attach that Google Sheet as well?
No, you don't need to. You don't. No. If you submit anything on Moodle, you are implicitly agreeing to anything that's on that cover sheet. So the cover sheet basically is I've submitted it to the correct class at the correct deadline time. It's my own work. I haven't taken it or copied it from anyone else. So the reason why we want the cover sheet is to identify who it's from, but that'll come up in your account. To have that little piece of paper written down that says, yes, I agree, this is all my own work, it's not anyone else's work. So the ownership and the plagiarism things are signed off. If you submit something on Moodle, it implicitly agrees to all of those. So you don't need a cover sheet, so you don't need to add that extra file in. I also don't need your class files. I only need the Java files. Now, if you only give me the class files, we have a problem. If you give me the Java and the class files, that's super. But what I'm looking for is just the Java files.
Like that. Like the first one I already
Correct,
did.
yes, yeah.
Stats and send.
Yeah.
And should we send all together?
Yes, so you create a zip folder of
Not
everything.
folder. Okay.
Any other questions? Either on the worksheet or anything else we've done up until this point?
There's something that I saw in the YouTube because I was looking at all the videos.
Okay.
Mr. Class and so on. And there was something about print, like draws, like a, no. I don't know. I was trying to find here in the middle, but I couldn't. It's not in the.
Printing to the screen.
Yeah, printing to the screen.
Okay, so
I think it is, but it's not in the YouTube channel. Like, it's not the name of this class.
it might be the very, very first class,
but it's not on YouTube.
but it might have been before I started recording. I only started recording this, I think, after the first class, I think. But it's very small, and I can show you that. Once we get through some of the content, let's say, yes, I'm
I know just because I do not use it.
Yep.
You're gonna ask it.
Did you do, well, show me your
I
question
tried.
one code. I'll be able to tell you whether you have it right or not. Yep. Yep, you understood. I'll say print to the screen, so that's all working there.
Yeah, no, I don't. I'm gonna start here. But
Okay, no problem. Any other questions? Everyone happy enough? So what do you want to do this evening? Do you want me to recap what we've done so far? Or would you like me to move forward? Move forward. Okay, all right, fair enough. Strings. Okay, so there you go. Strings are going to be, so far we've looked at variables, we've looked at integers, we've looked a little bit at doubles. We haven't, I don't think I've given you any question where you have to declare a Boolean variable. However, with our if statements and with our loops, we've had to use Boolean expressions. So we've done some sort of evaluation that will simplify down to either true or to false. So we've used Boolean expressions. We could store that answer by creating a Boolean variable. So Boolean b is equal to x greater than 10. And if x is greater than 10, it'll put the value true into variable b. If not, it'll put the value false into variable b. But we've used what are called primitive or simple data types. And they are exactly how I explained what a variable is. It's a box. I can put stuff in the box, I can read the stuff that's in the box, or I can change the contents of the box, but I can't do anything else. Strings are the first complex data type we look at in programming. We'll look basically at we'll look at strings as a data type. We'll look at this here, and that is a complex data type. It's an object. We will also look then at something called arrays, which is how we deal with collections. And then next year we go into an entire semester worth of just custom creating data types. So that have multiple pieces of information inside it, which would be our object-oriented class. But this is our first introduction to it. So we've seen that if we run that piece of code, 1 + 2 + 3 + 4 + 5, we kind of know what's going to come out of that. It's going to go, oh, that's a number, an addition sign, and a number. I'm going to add those two up, I know I've got a number and another addition sign, add those two up. A number, an addition sign, another number, add those up. And it keeps adding it until it's simplified that expression down to the number 15. Okay, so we understand that. That's reasonably simple. Well, what if I gave you that one? What if I gave you A plus B plus C plus D? What do you think I'd get then? And then to make things more confusing, what if I did that? What would I get? So strings, the reason why it's a complex data type is because it deals with a group of information. It deals with a bunch of things together. A string, as we've seen so far, is everything that goes inside quotation marks. So when we print something to the screen, it's a string. It's please enter your name. That's going to go inside quotation marks. That's going to be the string that we're looking at. Okay? And so far, we have written exactly what we want to be printed to the screen, as if it were a quotation. And we've done some things with the strings, where we said your answer is, and then plus, and then the answer variable. And that's called concatenation, where it takes text value and non-text value, and it adds it together, and now it all becomes text value. It's like you add the value, the numerals from your integer onto the end of that string. But a string is a collection of characters, individual characters that we can type in the keyboard. And so what we want to do is we want to look at how can we handle that group of characters. And once we have a group, so it's not just a letter A, it's not just an exclamation point, it's not just a bracket, which are all typable characters, but we have a bunch of them. Well, what can we do with that? How can we utilize that to our advantage? So what we're expecting is if we add 4 individual characters together, we're going to get this. Okay, and this is a string. We know it's a string, or we will know it's a string as we go forward, because when we looked at the previous example, we can see that each of these characters here have a single quotation mark or an apostrophe either side of it. But when we look at the string, we have a double quotation mark. Simple way of looking at this, especially from a learning point of view, if you see a letter or a number or a symbol which has got single quotation marks around it, that's a character. It can only ever be one thing. It can be one alphabetic character, either uppercase or lowercase. It can be one numeral, so some number between 0 and 9. Or it can be the symbols that you can type on the keyboard. If we see double quotation marks, well, then that represents a group. And that can be somewhere between 0 characters, so you can declare your string as just empty quotation marks, up to whatever size string you wish to create. Last year, for the repeat assignment, so in Griffith, and in most higher education, but in Griffith, if you don't pass either the assignment or the examination in the regular semester, you get an opportunity to do it again over the summer, or to do a supplemental assignment over the summer to catch up, so that you can clear the subject before we get to the new academic year, so you can move forward with your course. What happens with computer programming, because we have so much assessment throughout the year, it would be unfair to expect you to do something equivalent to all of that. So I usually set one large assignment, and that takes the place of anything that you did throughout the year. And last year, or well, August just gone, I got the students to create a spell checker program. And so the spell checker program, sorry, not spell checker, a text analysis program. So it would scan through the string, and we'll see how to do all of these actions ourselves, but it scans through the string to count how many words, how many sentences, how many paragraphs, how many words per sentence, what's the average word per sentence, what's the shortest sentence, what's the longest sentence, what's the average length of each word, what's the largest word, what's the smallest word, what's the most common character, not space character, in that text. And so you could send in any text you want, and we were dealing with text files, and it would process through all of that and produce at the end of it a series of statistics. This text file had 45,000 words. The longest word was 14 characters. The shortest word was 1 character. Most sentences had 8 words in it. The longest sentence had 25 words in it. And so it gave you all these statistics, and we were able to build up through it. And to give you an idea of the size of the text that we're dealing with, I think I gave 3 files. I gave a short Aesop Fables nursery rhyme, Tale of Two Cities, and then the entire works of Shakespeare. And the entire works of Shakespeare, which is the largest file, was able to be loaded up into a single string. So you can see that strings are massive compared to the other data types that we've looked at. The data types that we have looked at, like integer and double, Boolean, they have a limit. They have an upper limit and they have a lower limit. And even if we take the extended versions of those, like the long data type, which we've talked about but we've never used, that has a limit, and it'll get to a point where you've reached the end of the positive side of that. But with strings, your limitation is kind of the amount of memory you have in your computer. So it can keep growing, growing, growing. And each character in that string only takes up 4 bytes. So you could have a 10 megabyte file, a 20 megabyte file, a 100 megabyte file, which is 100 million bytes. So we're dealing with 25 million individual characters in that. So that's a huge amount of text that we're dealing with. So this is the idea of a string. And when we talk about a string, we're dealing with it with a capital S. Now that should be familiar so far, because every single program you've written for me, the second line of most of those programs was public static void main string args, and string was spelled with a capital S. And as we started doing our code, and as you go and attempt your programs, and oh, this isn't working, or this is our error here, one of the really common errors is you spelled string with a lowercase s, and it would show up an error. I don't recognize what this is. So here we have an uppercase s to declare string. If you declare it with a lowercase s, it'll break. The reason for this is string is technically something called an object. We're not going to deal with objects much this year. A little bit in the second semester, that's about all. But when you see a variable that is lowercase, the data type name begins with a lowercase letter, that's usually going to be a primitive variable. And if it begins with an uppercase letter, well, then that's going to be an object. It's going to be a complex variable. So string is a complex variable. Scanner is a complex variable. Random is a complex variable. And these are all ones that we've seen so far. Okay, so a string is going to be a collection of characters. A character is any key that you can type on the keyboard. So it includes all of your letters, it includes all of your numerals, and it includes symbols. Most people get the letters and the symbols immediately. The one thing that's worth noting is that a character is a number between 0 and 9. 10 is 2 characters. 100 is 3 characters. It's the numeral 1, and then the numeral 0, and then the numeral 0. So we just need to be aware that when we're dealing with numerical values in our characters.
What about negative? Is that another
Negative would be 2 symbols, because yeah, exactly, because you have the negative dash plus those values, which is why you wouldn't have every variable in your program declared as a string, because the space it would take to store it would become ridiculous as the numbers got bigger, when it would only take 8 bytes if we're using an integer. Sorry, not 8 bytes, 4 bytes. Okay, kind of talked about that. Where have we seen it before? We have seen it, well, we've seen it at the very beginning in our public static void main, but we've also seen it where we have our system that I've got print ln, and our string would go inside. And whatever we had in there, whether we had something in quotation marks, hello world, or we had concatenation of the answer is, and then the variable answer, which might have been an integer, or we just had 3 plus 5. In all of those scenarios, the way this works is it's all eventually calculated, converted to a string data type before it gets pushed to the screen. So as we simplify it down, we're trying to get to the point where there are no more expressions, or there's no more concatenation to be done inside this. And then when we get to that point, it's right, convert that whole thing to a string and push it out to our screen. The other thing I want to go back to is the idea that it is a collection. Collections in Java are, or in programming, not just in Java, in all programming languages, are a really powerful way of gathering similar things together. So a string is a really handy way of picking up a bunch of text and treating it as one entity or one unit. Imagine we had the entire works of Shakespeare and we didn't have the concept of a string. Imagine how many characters are in all those plays and all those sonnets. And if we had to have variables to represent every one of those characters, that would be ridiculous. Whereas if we have a string, we can gather them all together. The other thing that's worth noting is it's not just a mess of similar things. It's not just a bag where we've thrown everything in and everything's kind of jumbled up. Very much like the works of Shakespeare, the ordering of the characters inside those plays and sonnets will dictate what those words mean, what that text means. So it is an ordered collection. We have a way of working out what's the first character, what's the last character, what's the middle character, what's the next character. And that will be the basis for the majority of the work we do between now and when we finish for this semester. You will be sick of questions that revolve around strings, because I will get you to do all of those weird processing like count the number of characters, count the number of sentences, count the number of words, let the user enter in a number and reverse the nth word, reverse every other word, remove all the vowels, remove all the spaces, capitalize the start of every word, make sure that a sentence is correct so the first word after the full stop is also capitalized for the first letter. We will have the ability to do all of those calculations, all of those evaluations, and it will allow us to be really comfortable by the end of the semester with the process of, here's a string, I have to do some stuff to it. I know exactly the steps that I need to take to get from it not been processed to the processing been finished. So a couple of things to talk about. I've already mentioned this. Strings are going to be represented by 2 quotation marks, or double quotation marks. Characters are represented by single quotation marks or the apostrophe. That's the first thing. Second thing is going back to the idea that we have an ordered collection. Every character within the string has a slot that it fits into, and every slot in that string has an index or has a reference point so that I can point to a specific area within that string. The complicated part about that indexing is that our counting now will start from 0. So far in your life, most times when you started counting, you start at 1. With programming, whenever you're dealing with a collection, whether it's going to be an array, which we'll look at later on in the course, or looking at strings now, we will always start our counting, our indexing at 0, and we will work our way up from there. Takes a little bit of used to it, but then it becomes kind of second nature. It's why all of those numerical variables I declare, I start them at 0 rather than I start them at 1. It's because I want to slowly start kind of getting across that if your starting value for any number should always be 1 inside program. And we've lots more stuff to talk about, but that's the future. Right. I've said that strings are complex, that strings are more detailed than a normal variable. And that's absolutely true. Well, what do I mean by that? Well, there is some stuff that's beyond first year, which I'm not really going to talk about. And we're going to come back to that in second year and see, oh, here's another reason why they are advanced. And that's talking about the idea of objects. If you've done programming before, you've done object-oriented programming before, you kind of know the route that I will be taking. But what I want to look at is what I would call the special features that we have inside a complex data type. So what I mean by special features is that we have the idea of extra commands we can call. We have been using extra commands, special object features, since our first program. Every time inside your program where you have gone something dot something else, and you have ended that last part with brackets, whether there's something inside the brackets or whether those brackets are empty, that is what's called a method. It's an element of functionality inside that complex variable. So when we go system.out.print, empty brackets, that's calling the print function, and it accepts in an input and it prints it to the screen. When we have scanner.nextInt, and we have the empty brackets at the end, that's calling the next integer function, and it does the functionality inside of taking in the keyboard input and converting it into an integer for us. There are some really common methods that we need to have a look at inside the string object. And this is what an awful lot of our work with strings will involve around, how we utilize these. So I've got really 6 common ones we have here. This is concatenation is kind of the anomaly, but it's the one you've already seen before. So the one that's most useful is dot length. And what dot length is going to do is it's going to return back the number of characters in that string. So it'll take a string and it'll count all of the letters and all of the numbers and all of the spaces, the number of characters you have in there, and it'll tell you, oh, that string has 10 characters, 100 characters, 10,000 characters, whatever it may be. The reason why this is useful is when we start looking at processing our strings, okay, so doing something to the string, removing all of the vowels, capitalizing each of the letters, counting the number of words. To do that correctly and to do that efficiently, we want to have a systematic approach. Okay, what a systematic approach means is that we define an algorithm of some sort. That is how we are going to evaluate a character. And then we have a way of applying that to every character. Most people, if you give them a series of jobs to do, or you give them a list to do, or an ordered list to do, most people start at the top, do step 1, and step 2, and step 3, work their way down. If you think about the code we've been writing, and when you see it up in Notepad++, there's lines, there's numbers for each of the lines. And our code traditionally starts at the top, works its way from line 1 to line 2 to line 3 to line 4. So that systematic approach of I'm going to run the program, so I'm going to start at the top and evaluate each line as I go down. And yes, because of if statements, there are blocks we can skip sometimes. And because of loops, there are blocks we might do a couple more times than we need to, or then just once. But we're working our way down to the bottom of it. When you start a film, you start at minute 0, second 1, and you play it until minute n, second n. Okay, you play it until the end of the film. When you start a book, you start at page 1, you finish at the last page. And you read each of the pages in between, unless it's kind of like some weird Steve Jackson choose your own adventure thing. And we want to have the same idea. But the challenge for us and with strings is, if the user is entering the values, we don't know how big that string is going to be. It could be 100 characters. It could be 5 characters. It could be 10 million characters. So we need a way of making sure we check every single element within that string, and we go all the way to the end, but we don't go beyond the end. We don't attempt to go beyond the end. And what we can do is we can use string.length to return back a numerical size for that. There are this many characters. And then we know, well, how far do we need to go before we know we're at the end? Does that make sense? Okay. This one you will use probably in every single program that involves a string between now and forever. Like every program eventually will end up using this. Concatenation, we've seen before. It takes 2 strings, or it takes a string and some other numerical or some other data type, and it adds them together to make a single string. The one thing which we haven't come across, so the next 4 that I look at are newer ones. The first one I'm looking at here is equality. If I want to check to see if one string is the same as another string, I can't use double equals. That doesn't work for me. It doesn't work because double equals for checking if the left-hand side is the same as the right-hand side only works on primitive data types or on primitive variables. It works in int, and it works in double, and it works in boolean, it works in float, and it works in long and short and byte, but it will not work on complex ones. So we need to have the dot equals command. And so to check to see if string s is the same as string t, we would write s dot equals, and inside our brackets, we'd send in t. Something happens, and it returns back either true or false, depending on whether it does or does not match. Okay. If I want to access an individual character inside my string, I will use the char at command. So lowercase c, uppercase a for at. And inside the brackets, I will send in the index that I want to access. So I'll send in 0 or 1 or 2 or 3 or 4 or 5, whatever it might be. And what will happen is it will return back the character value of whatever I have. So if I send in char at 3 here, where the string has the value hello world, what happens is it goes 0, 1, 2, 3. That's the third index. It's going to return back the second L from that. And remember that it's going to count from 0, not from 1. This is going to be the second most common command you will use with strings. Because what our routine will be is if we want to check an entire string for something, whatever it might be, we are going to use the dot length to tell us, well, how many places we need to check. And for each place, we are going to use the char at command, and we probably will have a variable in here which is going to change over time. So maybe our loop counter. If our loop counter starts at 0 and the counter goes plus plus, so it goes up by 1 each time, that's a perfect thing to check position 0, position 1, position 2, position 3. So we make sure we've checked all of the positions. And I'll show you examples of that in a moment. Index of will return back the leftmost occurrence of whatever character you put in. So if you put in the character I for the word raining or for the string raining, it goes, is that I? No. Is that I? No. Is that I? Yes. Okay. It ignores everything else. It's found one instance of it, and it returns you back the index that that occurred with, which is the third position or the second index. The last one we have here is a substring. And a substring is where we copy out some of the characters from our original string to create a new string. So if I had a word interesting and I send in a substring, what I send is I send in 2 pieces of information there. I send in a starting point and I send an end point. And it copies all of the characters from and including the starting point up to, but not including the end point. So in this example here, where I send in 4 and 8, it copies out index 4, index 5, index 6, index 7, and then it stops, which will give us the word rest. So in here we have 0, 1, 2, 3, 4, 5, 6, 7, and then it stops before it hits 8. Okay, so it allows us to, for example, let's say I gave you a question where I got the user to enter in a string, and I wanted you to print out the second word backwards. Well, the first step to that is identify what the second word is. Second step is get that second word out into a string of its own. Third step is print it backwards. By the end of today's class, we'll be able to do that. Okay, there are 6 of our methods, or 6 of our special features inside string, and they're great. They're great for multiple reasons. They stop us reinventing the wheel. They're great because they save us time. Someone has already gone off and verified this stuff works, and we can utilize it to make our life a little bit easier. Are there any more? Yes, there are loads. I'm not expecting you to know all of those. I would like you to know, on a normal examination, on a normal examination, I would expect you to understand the dot length command, the character at, the index of, substring, and maybe 2 lowercase or 2 uppercase, and you can probably guess what they do. There are other ones in here. There's compare to, there's code point before, there's format, there's starts with or split or replace all or replace first. I'm not expecting you to know those. The reality is, and even though string is a very common data type to use, most people don't know how to use them, all of them, automatically. Unless all you do in your job is deal with string data types and you deal with all of these. And that's not even everything that the string data type has. That's just what I can get on one slide. A logical question to ask at this point is, all right, but how do I know what's possible in complex data type X? Well, the best way to do that, or the best way to look at that, is to go online and look at the documentation for Java. So Java and all programming languages have something called an API, which stands for an Application Programming Interface. Firepoint, nothing exists called Firepoint. So Java API. Most, and just to show you here, if you go Python API. Most programming languages have an official documentation of here's what the commands are and here's how you use them. So I can see there's Python there. If I went C++ API, I would get something there. So there is an equivalent for each programming language you look at and for each plugin or for each third-party thing you would do. So if you happen to be writing a program that required you to interact with Facebook or with Instagram or with Twitter, there is a Twitter API. So I can go Twitter, and it tells me from their developer's account, here's how you do it. And the API is going to explain to you exactly. So I want to search tweets. How do I do that? And it shows me the commands that I can use. Okay, it'll give me the commands that I can use for that. Same with C++, same with Python, and same for us with Java. Now, the problem with Java is, first of all, that's not a very nice layout of code. Let's go. There we are. There are all the core main libraries. Inside that, we have our classes, which go on and on and on and on and on and on. And inside each class, we have the subsection. That's kind of confusing. That's difficult to navigate through usually. So what I like to do is, rather than just looking at the API in general, I will look for Java API, and then what I'm looking for, string. And that will bring me to string. And then inside here, it gives me some information about the language format. Maybe it gives me an example or two of how it works. That's fine. But what I'm most interested in, and what you guys will be most interested in from the point of view of getting things to work, is the methods. And the methods will explain exactly what every method in there does, what every dot command does. So for example, we have char@, and char@ is going to return a character value at the specified index, which is the value you send into it, and the type it returns back is going to be a character. And it goes then through all of these ones here. And sometimes, not always, but sometimes when you click on them, and of course they don't do it for this one here, when you click on it, it gives you a bigger detail of what's happening, and sometimes they give you a sample of code to show you how it's working. So for example, typically none of these are working, or none of these have examples of them. There, get bytes. And so it gives you a quick idea of how to work, or maybe a sample of how to get the code up and running. And also, as you go forward, as a programmer, it tells you whether this is an active method or a deprecated method. Okay, so deprecated basically means it's a legacy method. It's not really used. You shouldn't be using it in new development. But if you've come across this command in your code and you're trying to decipher it, or you're trying to update from a previous version to a current version, it gives you an indication of when it was deprecated, and it usually will tell you, here's a better way of doing it. So it's the guidebook, it's the Bible for whatever programming language you're using. You will find as you go through this course on Java, next year you'll do a course which will involve a little bit of Python and JavaScript and PHP. The year after that, you'll have more Python. You'll probably have a little bit of C#. The year after that, you might have Ruby, or you might have different, maybe Android development. The API is the first thing. When you realize, oh, we're doing language X, go find the API for that, bookmark it, because that's going to be a great reference point as you're working your way through the content. Okay? It also means as you go through the commands, you get more familiar. If you're not 100% how that command works, you can look it up and go, oh, there's an example. Okay, one more slide. So that's fantastic. That's really, really useful. And it's great to see that there is so much documentation there to assist you when you come across a command you don't recognize, or you're wondering how to do a particular action. A word of warning, although the part-timers don't usually fall prey to this, but a word of warning. Just like I said when I was talking about your workbooks, that I prefer if you attempted and maybe didn't have a perfect solution, but you attempted and it was your work. I would also prefer that rather than, for example, let's say I set you an assignment to replace all of the uppercase letters in the string with uppercase letters with quotation marks around them, or something like that. There probably is a command in here that can do that. I would prefer you to work out the sequence of steps you would need to do if these commands didn't exist, rather than spending all of your time searching for that one shortcut command that will do the job for you. And the reason why I'm saying that is only because this is an academic setting. I'm trying to get specific learning outcomes across to you guys, and the way I evaluate them is looking at how you solve problems. So every module you take on this course, every year on this course, and the course itself has a series of things that need to be achieved for you to have the check mark of, yes, pass computer programming, yes, pass systems analysis, yes, pass foundations of computing. And that all kind of aggregates together to, yes, pass this degree. And if those learning outcomes aren't met, well, then you can't get to that final point of, yes, pass degree, or achieves degree status. So, very often I will set a problem there. There probably is a single command you can use to quickly do something. A great one is what I would ask students, and I've actually removed it out of here to stop students doing it. But when I'd ask students, oh, please reverse user input, okay? So take a string in from a user and print it out backwards. There is a .reverse command inside string. I don't want you to do that. I want you to go through the steps of taking each character one by one and printing them out backwards. Because I want to verify that you know how to process two strings. When you're outside of this environment, if you're doing work for somebody, so again, you're a part-time student, so the likelihood of you moving into technical positions between now and third year is very strong. So if you end up working as development, if you end up doing a Nixer for somebody, so you're doing a website for somebody or a web app for somebody or something like that, use any means necessary to get that job done. But when a grade is attached to it, when it's academic, there is a reason why we might make you do it the long way around. Fair enough? And I try to be as open as possible where if I ask you to, let's say, sort a collection of letters into alphabetical order or print out that string in reverse, I will usually say at the bottom of it, you cannot use this command. You have to do it the long way. Okay, so special features are awesome. There are loads more. I've just shown you today, APIs to see where you can find them. And the next thing we're going to look at is how would we create our own? So think about all the little programs you've done between now and the start of the year and now. Think about that legitimate date problem, which apparently was a nightmare. And think about, think about how many hours or minutes or days you put into that. Imagine how useful it would be if you created a little piece of functionality called legitimate date, which takes in 3 integers and returns back a Boolean value of true or false, and all that work's kind of gathered in there. And so whenever you had a program that involved the date, you could just say, oh, use that there, rather than having to reinvent the wheel every time. That's what we're going to look at the next topic. I could make that date question harder. There was one year I got students to enter in their date of birth, and it would be able to tell you what day of the week that was. which is, but to be honest, that is a small extension beyond what you did in the question. It seems like a massively difficult question. But what we did is we picked a year, usually around the 1st of January 1940, and we said, well, that is going to be a, whatever day it was, let's say Monday. And so if you know what years are leap years, and you know how many days are in the year, you can calculate exactly what day that will be. So they enter in any date, and they'll say, oh, that was Tuesday or Wednesday, whatever it was. I haven't done it yet, that might be the first assignment. Okay, what time are we at? We will do a very quick code example, and then we'll take a coffee break, and we'll come back and we'll work through 4 or 5 larger examples then, so you can kind of see how this is working. Fair enough? Okay. Before I shut down the notes, are there any questions so far? Does it seem to make sense? There was no code in that, so it's really just the concept that I'm looking at this point. Okay. There with that. Okay, close all the tabs. And I'll look at this. Okay. Here is the one example I'll do before coffee. I have my import at the top, so I can declare my scanner. I ask the user to enter in a string. To take user input for a string, there isn't a next string command. If we take in an integer, it's next int. If we take in a double, it's next double. If we take in a boolean, it's next boolean. But for taking in a string, the command is next line, which will take all of the characters that you type until you hit the return key. That make sense? And what I do is I declare my string with a capital S. I'll call it string S. I let the user enter in whatever they want, and I'm going to push it to that variable. So if I enter in hello world, it puts hello world into S. If I enter in my name, or if I enter in the first chapter of the Da Vinci Code, well, then it'll take all of that text and it'll put it into that variable. And then for printing it out, we print it out the same way we print out any other variable. Just give it the variable name and say, hey, print that. And it goes off and it prints it to the screen. So I lied. I'm going to do 2 examples. I'm going to do this, and then I'm going to do the dot length command. Okay, so we're going to open up our command prompt. To desktop. I'm going to Java C strings. Java strings. Okay, so enter in a string. So if I enter in on Carol, hello, class, then it just prints that out again. Not particularly interesting, but it's our first example. So let's adapt that slightly, like this thing here. And for our second output, we're going to print out. God. The length of that string. Okay, so the only new thing I'm adding here is on line number 10. I'm going to count the number of characters in that string and print that out to the screen as well. So here I'm going to compile. I'm going to run and enter in the same string again, and that has 24 characters in it. Does that make sense? Can everyone read that first of all? Is that font?
That takes spaces into account.
It takes everything, yep. So if I were to go across, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, it takes everything from the first character you type when you hit the enter key. If I were to write that again, it takes in all of those. So it takes in 81 characters in that ridiculous string list there. It doesn't matter if it's grammatically correct. You can see here I've got 2 capital letters, my surname. That doesn't make a difference. It doesn't care about your spelling. It doesn't care about the number, the punctuation. It doesn't care if you begin a letter with a capital letter or a lowercase letter. It doesn't care if you just like. It doesn't care. They are all typable characters. They are all valid as input. And see here we've got 67 characters in there.
But then the context of the customer first one is 0.
Yep. So this is index 0, which means that the last index, the one here for H, is index 66. which will be this the example. The first example we do when we come back. Okay. If we start to count, if we know this counts how many characters we have, but if we know we start counting at 0, that means that the reference point for the last character is going to be whatever this number is minus 1, and it always is dot length minus 1. Fair enough. Any questions on the code? Everyone's happy enough with it so far? I can make it more difficult if you want. Okay. In that case, it is just going up on 7:45. I'm back here for about 8 after you get a bit of coffee and fresh air, and we'll just go into work mode and do a whole series of questions on this with little pictures as we get bigger. Cool. And end.